He was hoping for world peace. All right. Okay. So you're writing, I forgot to put up the key to that assignment yesterday, but it's recorded now and ready to go. It'll go up when I put up this one. Make sure you give it a watch because it will be helpful for the test you're writing tomorrow. I left you there and I told you there was a third way to solve systems, which is what we're going to... This is my preferred way, but it's a little bit weird as to why it works. So I like to spend some time with it. So, the first thing we will do is we will solve this system by a graphing. So, I'm just going to get a coordinate grid going here. You could say that if you buy into that sort of thing. Terrific. Now, as always, I will be graphing this in the easiest way possible, which is to isolate y. 3y equals negative 4x. Y equals negative 4/3 x. And, of course, negative 3y equals negative 5x plus 27. And y equals 5/3 x minus 9. So, y-intercept of 0, slope of negative 4/3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And 1, 2, 3, 4, 5, 6, 7, 8, 9. And up 1, 2, 3, 4, 5, and over 1, 2, 3. And there is my solution, which we know to be 3, negative 4. Yeah? Okay. I'm a little confused as to why I'm hearing no, no, no. All we did was graph 2 lines.
I'm just a little, we're just a little, yeah, I'm just like a lot of slow. Oh, we understand. We just, whoa.
It was graphing 2 lines, guys. Y-intercept, count for slope. I'm trying to be nice and supportive here, but by this time, to not be able to do this is a little bit disconcerting to me. Especially when I heard that Mr. Deweydoff at least showed you some slope-intercept form before I got even a hold of you. Does everybody have this graphed now? Good. Does everybody understand why the solution is 3, negative 4? Excellent. Now, work with me here. You are going to need to do something. I'm going to tell you what not to do, and a bunch of you are going to do it anyway. Every single one of you, without saying anything out loud, pick a number between 2 and 9. Do you all have it in your head? Excellent. Take that number, I'm just going to write the number sign, and multiply it by the second equation. So, what you are going to do is you're going to take your number and you're going to multiply it by 5x minus 3y equals 27. Whatever your number you have, you're putting it there, and then down here, you're going to isolate for y. So if I chose to do 3, Mine would be 15x minus 9y equals 81. I lie, not 81. Sorry. Yeah, 81. And then I would solve it for y. Go. And of course, what do you notice? What do you notice? Now, that concept has been following you through math since the very first day of fractions. Because 1/2 equals 3/6. Because you multiplied both by 3. It is also why proportions work. If you go 1 centimeter on a map, you go 10 kilometers in real life. That is why this works. This concept. So, not only is multiplying both sides of a linear equation result in the same line, multiplying any mathematical expression gets you the exact same results, even though it looks different. Everybody understand that? So, how does that help us? Multiplying both sides of a linear equation results in a new, and put new in quotation marks because it's not new, a new equation that yields the same results. In layman's terms, not math terms, it looks different. Okay? If we need to change a linear equation to work with, we can multiply it. Everybody cool? Now be intelligent for me. If you can multiply it and have it stay the same, what else can you do? Divide it and have it stay the same. Thank you. That is the first section of the second version of solving systems. The third method of solving systems. Next, add those equations. Oh, add an equation. That seems weird, but we've already done it in grade 10. We've collected like terms. What is 4x's plus 5x's? 9x's. What is 3y's plus negative 3y's? 0y's. What is 0 plus 27? 27. What would you do with that? Solve it. X would equal 3. Right? Now, first, we're going to explain what happened math-wise. What happened mathematically? And then what was the result? What did we end up with? Before we got 3, what happened? Thank you. The y value was eliminated. Once the y value was eliminated, I was left with an x value, wasn't I? And if I take that x value and I graph it on the grid I had above, which I'm going to do right now, you don't even need to. Look where it goes. Right through the solution again. Okay? Everybody with me? Excellent. So, we've added, and we managed to eliminate a variable. What happens if I subtract? What's 4 minus 5? Negative x. What's 3 minus 3? Positive 6y. And what's 0 minus 27? Did anything get eliminated? No. But what would happen if I took this and I graphed it? Well, right now, is that easy to graph? No, it's not, because it's not in a good graphing form. Can I put it in a good graphing form? Of course I can. I would end up with y equaled 1/6 x minus 4.5. Because 27 divided by 6 is 4.5. Is everybody good with that? It's just algebra. We're all good with that, right? And if I put that on the graph, where is negative 4.5? 1, 2, 3, 4.5. Right there, correct? And my slope is 1/6. Up 1 and out 6, correct? Where does that line go through? Right through the solution again. Wait! Wait, there is more. If I add or subtract the linear equations, what do I get? Again, results in new equations which still have the same solutions. So how does that help us? What that means for us is we can use algebra to rewrite our problems so we can work with them. Now, coming back to our graph, you guys don't need to graph anything. I'm just going to show you the graph. I'll let you, this will come back on the screen if you're not done writing it. Don't worry about it. I have, I should have made this line a different color. Let's make that line hot pink. Now, of those 4 lines that we have graphed, the red one, which has a negative slope, the blue one, which has a steeper positive slope, the hot pink one, which has a less positive slope, and the gray one, which is straight vertical. Which of those 3 is useless to finding the solution to the entire system? The straight vertical line, because the straight vertical line only gives us what? It only gives us an x value, because that straight vertical line has an infinite number of y values, yes? But that straight vertical line is the line that did what in our system? Eliminated one of the variables, which is the reason we can't solve the system, isn't it? When there's 2 unknowns, we can't solve it. So this move becomes very useful in helping us solve the system, but not very useful in giving us the final answer. Does everybody understand what I'm saying? All right. If you are good with that and you understand what is going on, every single one of you should be able to write a third equation right here that will have the same solution. Very unlikely that any of you will write the same third equation. Everybody write one. I'm going to write the general and I use the term general form with small letters. I'm going to write generally what you could put here. I don't want to use that.
Why is it 17?
18. Oh, wait, I added the first one. Yes, sorry. That one's 19, and this one is 17. Thank you. What does this black one mean? I could have multiplied this by any number. No matter what number I put there, I will get another equation that has the same solution. Or I could have used some other number with this one. Or I could have added them, and I should have done this a different color. Or I could have subtracted them. Does everybody understand, Suhani? Again, I said you could have done any of these four things. You only had to write one equation. The chances of all of you writing the same thing are very, very slim, because you would have had to choose to multiply by the same number on the same equation. Yes, McKenna?
So you just subtracted the bottom thing.
Mm-hmm.
And that's what you did.
That got me a third equation that I could have used. Okay? We've just proven that using the graph. Is everybody good? All right. Let's put this into practice. You now know that you can multiply either equation and you will keep the same result. You know you can add them together and you will keep the same result. You know you can subtract them from each other, you can keep the same result. And you know that you can add them together to eliminate a variable or subtract to eliminate a variable. That is everything you know so far, yes? Let us apply it. Turn the page over, cabbages. Step 1, which I am doing in green. Add or subtract the equations to get rid of one variable. Get rid of. Eliminate. So, what variable here is it easiest upon looking at it to get rid of? The y. Why? Because they are, Brandon? They are opposite coefficients, right? So, how do I get rid of two opposites? I add them. I know, that's why I'm fixing it. So I'm going to add these. And I'm going to do that in green. What is 3 plus 4? 7x. What is happening to my y's? They are gone. What is negative 9 plus 23? It'll come up. We've decided we're adding the equations. You don't need the screen to add the equations. What is negative 9 plus 23? 14. That is step 1. Step 2, I will write in hot pink. What does it say to do? Solve for the remaining variable. How do I solve that? Divide by 7. What does x equal? 2. And then in sassy blue, we will plug that value back in. Where can I plug that value in? To any x I see. One of those three x's is useless to me, though. Which one? I always say you can plug it in anywhere you see it, and then some wise ass always says, I'm going to put it right there. Why is that useless? Because I know that one. I'm not looking for x, I'm looking for y. So I have to plug it into an equation that has a y in it. Right? So what are my two options? I could go 4 times 2 plus 5y equals 23, which would get me 8 plus 5y equals 23, which would get me 5y equals 15, which would get me y equals 3. Or, in a slightly less sassy blue, I could have gone 3 times 2 minus 5y equaled negative 9, 6 minus 5y equaled negative 9, negative 5y equaled negative 15, and y would still equal 3. Because it does not matter where I substitute it back in. Because this, if I read it in English, says for this question, x equals 2. So every x in this question is 2. Is everybody cool? Now, this is the third method for solving. I generally use this method most of the time. However, you can always choose, except for the one question on your test where I force you to use elimination, then I will force you to use substitution, then I will force you to use graphing so you can prove you understand all three. Okay? Any test that I give you will have instructions. If they don't have an instruction for how to solve the system, you can solve it any way you please. Okay? Okay. What is wrong? What is different about this side? It is not automatically apparent where to cancel, is it? Which means I must change the looks of one or both of the equations. What allows me to change the looks? Multiply. What should I multiply? If I multiply the top one by 2, will that work? Could I multiply the top one by 3? Yes. Could I multiply the top one by negative 3? Yes. Who makes that decision? You do. Can I tell you the right way to do it? No, because there is no right way to do it. You will understand what is going on and do the version that you see fit. Please take the whole case. Thank you so much. Which way would you like to approach this? 2? All right. So when we multiply by 2, we are going to get a new equation. That new equation is going to be 2x minus 4y equals 14. Now what can we do when it's set up for us? What will we do? Add them, because when they are opposite signs, we must add. What if they're the same sign? Subtract. Since they are opposite, we're going to add. What is 3x plus 2x? 5x. What is 1 plus 14? 15. What does x equal? 3. And where does that 3 go? Any x I like. I feel like putting it in the very first equation. 3 minus 2y equals 7. Minus 2y equals 4. Y equals negative 2. What is my final answer? 3, negative 2. Mr. Myers, did I do it right? Did I do it right? Kid, did you check it? Did you check it? Do I need to check this one? No, because that's the one I just used. So what's the only one I need to check? This one. What is 3 times 3? 9. What is 4 times negative 2? Negative 8. What is 9 plus negative 8? 1. Did we do it right? Kid, you did it right. Kid, you did it right. Everybody good? Why not? Ganika.
Why is it that we can choose whatever number we want to?
Because all you're doing is trying to get any of the coefficients to be the same. So you can eliminate one.
So the coefficients always have to.
If you're going to use elimination. Now, what is happening over here? It's a colossal mess. But you can. How would you add 1/2 and 1/6? Oh, I lie. 1/2 and 1/3. I gave it away. You would multiply this by what? 3. And you would multiply this by what? 2. So how do I get 3 and 2 to be the same number? Multiply the top one by what? 2. And multiply the bottom one by what? 3. One positive, the other positive. How can that be? It's okay because I will still end up with opposite signs here, won't I? What is the new top equation?
Why didn't we multiply?
Stop. Catherine first.
Why didn't we multiply the second one in the first place?
Oh, because we didn't need to, because 2 and 2 became 4.
Oh, okay.
Right? If you were adding 1/2 plus 1/4, you wouldn't go to eighths, you'd just go to fourths.
You wouldn't do it if you didn't need to?
No. Why would you do extra math if you don't need to, right? What?
Never mind.
Okay. So, what is my new top equation? Equals 40. What is my new bottom equation? 33x plus 6y equals negative 3. What math will I do there? Addition. What is 4 plus 33? Equals, what is 40 minus 3? What does x equal? 1. Where does that 1 go? Anywhere I want it to. So I am going to put it in for 11x this time because I used the top one last time. 11 times 1 plus 2y equals negative 1. 11 plus 2y equals negative 1. 2y equals negative 12. Y equals negative 6. Mr. Myers, I do it right? Kid, where are you checking? Am I checking the 11 or should I check 2x minus 3y? I could check either one, but I just used the 11 one, so I know it works. What's 2 times 1? 2. What's 3 times negative 6? What's 2 minus negative 18? No. 2 minus negative 18. Positive 20, because minus a minus is addition. Everybody Gouda? Yes, I'm aware. I'm well aware. See?
I like this one and the one before the graphic.
I like this one and then nothing else about systems.
I like this one and the solve by substitution.
Okay. I'm glad you like them both because then, no matter what the question looks like, you're going to be ready to go. Because sometimes substitution is the better choice, even though they will both get you to the same answer. Right? I like how you sat there waiting for me to bug you or zing you in some way, and it was all complimentary. And now you don't know what to do with yourself. Because you were all prepared for an attack. Even though I don't attack. I attack some of you. I don't attack you. You attack me. I play defense.
I'm defending my classmates.
Okay. Huh? No, it's not. I told you guys. I showed you. I made a spreadsheet for it. That's how much I care. Yes, I made a spreadsheet. Because I'm a super nerd. Now, stop, please. Stop, please. Stop, please. Stop, please. Stop. You now should be fairly comfortable with all things system. Yes? Okay. 8.4 is a weird little lesson. It's nothing new, and it literally takes 5 minutes to show it to you. But for some reason, over the course of the years, it has evolved into getting its own lesson, because for some reason, people cannot figure it out. This is a year that I'm going to try and see if you indeed can figure it out in the 5 minutes it takes. Everybody ready? Let's do this thing. Graph this. Graph it. However you see fit. But what you must do after you graph it is compare the properties of the lines and each form of the equation. Is everybody good? Those of you that have graphed the lines, the next thing I asked you to do is compare the properties of the lines and the forms of the equations. What are the properties of the green line? You can only tell two things about a line from looking at it. What are those two things? You can find the slope and... No, there is no solution to a line. You can tell the slope and all coordinates, right? Sometimes you'll get an exact y-intercept, but not always. Okay? In the case of the green line, can I tell the slope? Yes, it is -3/4. Can I tell the y-intercept? Yes, it is 6. So the green line has a slope of -3/4 and a b of 6. Agreed? Okay. What are the properties of the brown line? -2, and what is its b? 11. Now, what do you notice? You have two different slopes, you have two different y-intercepts, so that means the lines have to cross somewhere, don't they? If they cross, they have how many solutions? 1. What is the maximum amount of solutions this system can have? 1. So, If it happens once in math, it happens always in math. Different slopes, different b values equals one solution. Everybody agree? Yeah. And it can't be more than one because they're straight lines. They don't bend, right? The brown line is going to go off forever over that way. The green line is going to go forever over that way. And they'll never touch again. Everybody cool? Okay, that's a minute and a half. What if I graph these two? 4y equals negative 2x plus 12. Y equals negative 1/2 x plus 3. 2y equals negative 1x plus 12. Y equals negative 1/2 x plus 6. Graph them. 1, 2, 3, 4, 5, 6. Negative 1/2. And blue. 1, 2, 3. Negative 1/2. What is the blue M? You're being tested on this tomorrow. What's the blue M? What is it? Negative 1/2. What is the purple M? What does that tell us when we know two things have the same slope? They're parallel. Which automatically means what? They'll never cross. Which means how many solutions? No solutions. So why am I showing you this? As the systems get more and more complicated, you're going to have to do more and more algebra. But if you can understand the forms that the equations take, like slope-intercept form, you can do a quick check and see if it's worth bothering to do elimination or substitution. If you saw they had the same slope and different y-intercepts, you know they're never going to touch, so why would you do any more work? Everybody with me? Okay, good. Let's do the third one. Do that guy. I've already used purple. I'm going to use orange. Without even graphing, what's going to happen there? Parallel? Look closer. Let's graph. Where's the orange one going to be? 1, 2, 3, 4, 5. That's 5/3, right? When I change the scale, right? There's a slope of negative 2/3, yeah? Where's the blue line going to be? What's that? Negative 2/3. Plus, what's that? 5/3. Where's the blue line going to be? It's going to be right on top of the orange line. How many times do those lines touch? So how many solutions are there? Infinite. Same lines intersect infinitely. So, infinite solutions. Easy peasy. That's the whole concept, the whole lesson. I've had to make that its own 80-minute lesson in previous years. Did it need to be? I know, right? I don't get it. but in previous years I've had to give this its own shot. Intersect. Now, how does this help us? I got 3 systems here. What's this first one going to be? What are my options? I can have 1 solution, I can have 0 solutions, or I can have infinite solutions. What one's going here? It's hard to tell, Mr. Myers. I know it's hard to tell because you can't see the slope until you do what? Isolate it. Y equals negative 1/2 x plus 3. What's this one? Y equals negative x minus 2. How many solutions? 1. Why, Thomas? Because they have different slopes. Let's do B. 5y equals negative 3x plus 9. Y equals negative 3/5 x plus 9/5. Yes? Y equals 18 over 10 minus 6 over 10x. How many solutions in the middle guy? Infinite. Why? They're the same line, but I switched the order to see how many people, and I didn't simplify the fractions. Because a great many of you, as soon as you see a different order, a different not simplified fractions, think it's different.
How did you go from 3 over 5x and 9 over 5x to 18, 10 minus?
When I isolated that y in the second equation.
Oh, okay.
Cool? And lastly, obviously we know it's going to be the 0 one, but what have I done to make this useful mathematically? I changed the letters, right? Who decides how to isolate? You do. If you isolate Q, then Q is your Y. Understand? If you isolate P, then P is your Y. And you check the other one because that's your slope. Everybody get it? So if I isolate P, then 2P equals 5Q plus 30. P equals 5/2 Q plus 15. Yes? So then I isolate P again. 4P equals 10. Oh, I wrote that as X. 10Q plus 15. Divide by 4. P equals 10/4 Q plus 15/4. 5/2, 10/4. Same slope. Same slope, different y's. 0 solutions. Everybody good? Great. I don't think any of you really need to practice this too much, but I put a page in there for you anyway. More importantly, I would do some practice on elimination, which is page 283. If you feel good about it and you want to see another funny joke, you could do 284.
Is it as good as the last one?
It's almost. The last one is really good. This one is probably my 3rd favorite of all the puzzle sheets I use from grade 9 to 11. My first favorite is world peas. My second favorite is what do you get when you cross a centipede and a chicken? Extra drumsticks. Centipedes have 100 legs. So if you cross it with a chicken, you'd have a chicken with 100 legs. So you'd have extra drumsticks. Because that's what you call the legs of chickens when you eat them, drumsticks. So what's not to get? I disagree. That's fine. We're allowed to disagree. You thought Paul Blart Mall Cop was comedic genius. I know. Yes, we're parallel lines. We will never meet on funny. What, Preston? I can't hear a word you're saying. This year I'm teaching 2 blocks of pre-calc 11, 2 blocks of pre-dip 10, and 4 blocks of... No, 3 blocks of regular 10, because you teach 7 blocks. I don't know.
Do you teach IB?
No. Mr. Keeley and Mr. DeVries hog it for themselves. And that's okay. I see all of you guys in grade 10 because they don't teach any of the pre-dip 10s. You guys, when you go up into IB, they like the way you're prepared when you come through this room. So I get the 10s. Because you think I'm mean. You just wait. Not saying nothing. Yes. If you cross a what in a centipede? Yes. It would make... Centipedes aren't poisonous. Yes. Most poisonous animals, their meat is not the poison part. Their bites are. If you want to eat a rattlesnake, you're able to. Huh? Eventually. No. That's Thursday. Friday is... Friday will be we will mark the Unit 8 review. Oh! Ladies and gentle people. I'll leave this recording. Ladies and gentle people, please listen. Couple of things. One, remember, you are not going to be tested on systems. There will be questions on your final on systems, and the review in your book will be marked like all reviews in your book, so you have demonstrated some knowledge of systems. Okay? Point 1. Point 2. You are going to be writing your numeracy exam on Wednesday. When you write that numeracy exam, it is indeed the 23rd. All day on Wednesday is it going to be the 23rd. You are going to write that numeracy exam on that day. I promised you that you would see some examples of that over the course. Now, not tomorrow because you're writing a test, unless everybody finishes their test early. Thursday and Friday, I will be showing you some samples of the types of questions that are on there. Here is the type of thing you need to worry about. Cynthia has $386.84 in her bank account. She wishes to buy a $687 television. Can she afford to do so? That's the level of question that you are facing on this numeracy exam. Wait for it. Then the next part of that question would be, what are some options she could do to purchase the stereo? Get a job. Borrow the money. Get a credit card. Listen, please. Listen, please. Listen, please. You know what? Screw it. Okay.